This is 3-6, all about multiplying matrices. Okay, by the end of this, we will be able to multiply matrices. Follow along with me on page 14 of your notes packets. Okay, so this concept of matrix multiplication, last lesson we looked at matrix operations with addition and subtraction and scalar multiplication. But that all just had to do with numbers, right? So this is matrix multiplication where we're taking one matrix and multiplying it by another one. Okay, so order matters in matrix multiplication because the inside numbers of the dimensions have to match. Otherwise, the matrix multiplication will be undefined. Okay, so remember, every matrix has dimensions, rows by columns. So matrix A has dimensions 3 by 5. It has 3 rows and 5 columns. Matrix B has 5 rows and 1 column. So what this means is that to multiply matrix A times matrix B, that would mean we're going to take a 3 by 5 matrix and we're going to multiply it by a 5 by 1 matrix. So in order for this to be defined, we have to do it in this order because these 5s match. Right, so the columns of the first matrix have to match the rows of the second matrix. So A can be multiplied by B, but what about the opposite? What about if we took matrix B times matrix A? Well, 1 and 3, those do not match, so no. A times B would be yes, B times A would be no. All right, so let's say that we do multiply A times B. We take the one that is defined. It's going to have a product. The product is going to be another matrix, and the matrix dimensions are going to be the outer numbers. All right, so this is going to turn into a 3 by 1 matrix. So when we multiply a 3 by 5 times a 5 by 1 matrix, we end up with a matrix with 3 rows and 1 column, which would be like this. It'd be kind of like a tall, skinny matrix with a number here, a number here, and a number here. Those are just examples. That's not the answer because these matrices, we don't see them, right? So that's the first thing you always have to check with these example problems are, can we even do the multiplication? All right, so this is example 2. All right, so we have a 2 by 2 matrix and then another 2 by 2 matrix. So all these are 2s. This is probably the most common and the easiest type of matrix multiplication to take care of because the 2s are the same on the inside, and the solution is going to be also a 2 by 2 matrix, something like this, with a number, 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 number. Okay, so to get this top left number in the matrix, we're going to take the first row and multiply it by the first column, and then we're going to add those together. All right, so this is really important. We have to be very careful with how we do this, and this is actually why those middle numbers have to match, because otherwise this process won't work. All right, so we have to take 1 times 5. I'm going to write a bigger matrix down here. All right, 1 times 5, and we're going to add that to 4 times 9. So notice how we're taking the first top left number times the top left number, top right number times the bottom left number, and that's going to overall give us this top left value in the matrix. All right, and then let's keep going. So that's I'm going to write a little star here. All right, and then to get this top right number, we'll take our top row times our right column. All right, so 1 times -7, we're going to add it to 4 times 6. And then to get this bottom left number in the matrix, we're going to take our bottom row, again, times our first column. 3 times 5 plus -2 times 9. And then to get our, let's see what color, I'll go to black, I guess. To get this bottom right, we will take our bottom row times our right column. So 3 times -7 plus -2 times 6. Right? And then we're going to simplify, and then we will have our matrix. Okay. So 1 times 5 plus 4 times 9 is going to give us 41. This is where you just want to be careful with those calculations. 3 times 5 plus -2 times 9, we will get -3 down here. And then top right, 1 times -7 plus 4 times 6, we will get 17. And then our bottom right number, 3 times -7 plus -2 times 6, we will get -33. That's going to be our matrix. We have a 2 by 2 matrix with those values for its rows and columns. Okay, so notice, take a second and just notice what's going on here. So in the setup, we see our new first column is both being multiplied by our first column, 5, 5, 9, 5, 9. All right, and our top row is 1, 4, 3, -2. So if you kind of study this, it will start to make sense. It just takes some practice. Okay. So here's our next example. First thing we have to do is check and see, can we actually multiply these? So here we have, let's see, we have one row, we have a 1 by 2, and we're multiplying it by a 2 by 1. So the inside numbers are the same. So we're good to go ahead and multiply these, and the answer is going to be a 1 by 1. So our actual matrix solution is just going to be like one number in brackets. Feels kind of funny to do that, but that's what we're going to end up with. All right, and so we're just going to take our row. I like to circle them because it makes it really clear what's happening. 5 times 6 plus -1 times 2. And then when we simplify this, we get 28. That's it. 28. All right, and so when we get down to example 4, let's see what's going on. All right, so these matrices look the same, 3 by 2, 3 by 2. It's tempting to say, oh yeah, they're the same, so obviously I can just move forward. But notice the inside numbers are not the same, so this actually is going to have no solution. All right, say you didn't notice that though. All right, say that you just kept going. Let me write that down first. No solution or undefined. Okay, say you didn't notice that and you tried to keep going with your process. So circle your first row, multiply it times your first column. 3 times 4, whatever. And then you take your second row, multiply it times your second column. But then the problem is, like, you reach this point with the bottom row, and there's no more columns to multiply it by. So that's why this is undefined, right? That's kind of the big idea. Final example. Pause the video, give this a try. It's a higher order thinking problem. Right? If you are just totally stuck, or if you're, you've paused the video and you've given this a try, then that's great. All right? But this is an example where Alex likes to give you these problem types a lot, so you might see this in your homework. But the idea is that we're taking this top row, multiplying it times this column, adding it together, and when we do that matrix multiplication, it's going to be equal to this value in the top left. Okay, so we can actually create a system of equations here. -2 times x minus 6 times y should be equal to -18. And then think about, I need another system with x and y. So instead of doing -2 and -6 times this second column, I'm going to actually just jump down and say, okay, I want to take 6 times 5, multiply by x and y, and then which number is that going to give me? It's going to give me this bottom left number, 28. Right? 6x plus 5y equals 28, and now we have a system of equations, system of linear equations, so we're going to label them A and B, and we're going to solve them with elimination. So from here you should feel pretty comfortable with this. Proceed at your own pace. Notice that this -2x, if we multiply it by 3, that'll give us a really nice situation. All right, so 3a plus b. So 3a I'm going to write out is -6x minus 18y equals a -54. And then b is 6x plus 5y equals 28. And then when we add, we're adding because we have -6x and +6x. When we add, we're going to get -13y equals -26, meaning that y equals 2. y equals 2. And then we can use substitution and sub this back into either of our initial equations. Doesn't matter, either one's fine. I'm going to choose the top one, negative 2x minus 6 times 2. That should be equal to negative 18. So then let's simplify and solve. Negative 2x minus 12 equals negative 18. Negative 2x equals negative 6, and x equals 3. All right. You don't need to write your solution as an ordered pair here because that's not the notation that we started with. All right. X is 3, y is 2. That's all. Go ahead and give your practice a try.